This is the first example of using subgoal labels to evaluate an expression in the Java programming language. Here are the subgoals. First, determine the resultant data type of the expression. 2. Update the variables for any pre-operators, noting any side effects. 3. Solve the arithmetic equation using operator precedence. In other words, determine the value of the expression. 4. If there is an assignment statement, is the left-hand side a variable? Check the data type of the copied value against the data type of the variable. 5. Update the variables for post operators, noting any side effects. There are several examples using these subgoal labels. This is the first example. In this example, we'll be looking at declaration and initialization of variables. Here's the problem statement. Evaluate these statements. If the statement is invalid, give the reason. If the statement is valid, what are the values in the variables? Below, we have declarations of several different variables. We will walk through each of these. Subgoal 1 is to determine the resultant data type of the expression. So let's look at the declarations. Alpha, beta, and gamma are all declared as integers. Beta is assigned the value of 1, which is an integer and is a legal value. Omega, theta, and lambda are all declared as doubles or decimal numbers. And omega is assigned the value of 2.5, which is a double and a legal value. Now let's evaluate each of the next statements. The first one is alpha is assigned the value of 42. So the value of the expression 42 is an integer. Theta is assigned the value 4. The value 4 is an integer. Gamma is assigned the value 0.0, and the value 0.0 is a double. Lambda is assigned the value of beta, and beta is an integer. Subgoal 2 is not used in this example. Subgoal 3 is not used in this example. For subgoal 4, we're looking to see in assignment statements, is the left-hand side of the assignment statement a variable? And then check the data type of the copied value on the right-hand side of the assignment statement against the data type of the variable. So first we have the statement, alpha is assigned the value of 42. Alpha is a variable of type integer, so you can assign an integer to it, and we already noted that 42 was an integer. So the value 42 can be assigned to alpha. Theta is assigned the value 4. Theta is a variable and is declared of type double. We already noted that 4 was an integer. You can assign an integer to a double. The integer value 4 is promoted by adding a 0.0 to it so that it becomes 4.0, and the value 4.0 is copied into the variable theta. Gamma is assigned the value 0.0. Gamma is a variable and is declared of type integer. You cannot assign a double to an integer, therefore this statement is invalid. Lambda is assigned the value of beta. Lambda is a variable of type double. Beta is a variable of type integer. We noted that you can assign an integer to a double, so that the integer value that is in beta, 1, is promoted so that 1.0 is copied into lambda. Subgoal 5 is not used in this example. So for the answers, we have that alpha contains the value 42, beta contains the value 1, omega contains the value 2.5, theta contains the value 4.0, lambda contains the value 1.0, The assignment to gamma results in a compilation error because you cannot assign a double to an integer. That is the end of this worked example.